Elnik Systems is a global leader in debinding and sintering equipment. They produce metal injection molding furnaces that serve a key role in the metal 3D printing and additive manufacturing industries. These furnaces can reach internal temperatures of 2900 degrees Fahrenheit, which forces them to use high temperature alloys like molybdenum inside their furnaces to keep all the heat inside with heat shielding. In order to keep this shielding in place and hold the furnace together, Elnik requires the use of shield pack anchors made from molybdenum wire. Currently, thousands of these shield pack anchors are produced every year. The process is done 100% manually, which requires valuable man hours and creates lower dimensional reliability, which is why the Elnik Form senior design team was tasked with creating a machine that automates this process by taking a spool of wire and ejecting a fully formed anchor. The team began by researching the properties of molybdenum wire and its restrictions for cutting and forming, and then decided on a finalized design that utilizes 6 different subsystems. The first component is the spool holder, which employs a motorized lazy Susan that holds the wire and keeps it in sync with the rest of the system. The next subsystem is a wire straightener that straightens out the wire coming from the spool and prepares it for bending. From the straightener, the molybdenum wire is brought through using the feeding mechanism, which pulls the wire through using a motorized stainless steel extruder gear. The wire is then fed through to the bending mechanism. All the bending operations are based upon the tool steel nozzle, which was designed by the team to standardize the bending process. This nozzle was manufactured using one of Elnik's metal injection molding furnaces, as well as the Duke machine shop. Part of this bending process requires a wire crimper to ensure that the wire gets bent a full 180 degrees. The final mechanism is the cutter, which cuts and ejects a fully bent anchor through a chute and into a storage container to be installed into the shielding of Elnik's furnaces. The power and control system is housed in an electrical box mounted underneath the machine, which provides protection in the event of an overcurrent or machine failure. The HMI touchscreen, mounted at the front of the machine and next to the emergency stop, provides full-fledged controls such as on-off, speed control, and selection between continuous, timed, and anchor count-based running modes. Once our design was finalized, the team began prototyping our system. As parts were procured, the controls team began testing on each subsystem with 3D printed versions of each. In cohesion with this testing, the mechanical team worked in the Industrial Solutions Laboratory to build the system, which included drilling, fabrication, welding, manufacturing, and assembly. The system was tested to verify that all controls function properly and that the emergency stop properly shuts down the system within 3 seconds of being pressed. Our design and product meet all the desired specifications and will serve a key role in Elnik's manufacturing of furnaces by reducing man hours and increasing dimensional reliability.